Alright, let's begin Chapter 5 in your Serve Safe book, The Flow of Food. Kind of looking at an introduction. What we're going to talk about in this chapter will be preventing cross-contamination, looking at time and temperature control. So you're going to know about how to prevent cross-contamination, looking for methods to prevent time and temperature abuse, different measuring devices, how to maintain different temperatures, etc. So that is what we're going to be talking about. Two of the major aspects we're going to look at in the flow of food is preventing cross-contamination and preventing time and temperature abuse. If you can kind of see through the flow of food for any type of operation, it doesn't matter if it's a restaurant or if you're talking about a large-scale packing house, you're going to have the purchasing, receiving, storing, the preparation, and then eventually some type of maybe a heat treatment, like cooking in a restaurant, some type of holding, cooling, reheating and serving. Now, all those are applicable to every single operation, but cross-contamination can happen during any one of these aspects of a food operation, and also got to prevent time and temperature abuse as well. Let's first look at preventing cross-contamination in certain types of food products. There's a couple of things that you can do in a food operation, no matter, again, restaurant, child care center, cafeteria, packing plant, whatever it is keep separate types of equipment for separate operations. A lot of places you're going to find a physical barrier between raw and cooked foods. You're also going to find in a major packing plant a physical barrier between harvest or slaughter and the actual processing, grading areas, stuff like that. So use separate equipment or rooms, if it will, for different types or different processes through the operation. Obviously, cleaning and sanitizing becomes very important for work surfaces, equipment, also the individuals. We have talked quite a bit about personal hygiene. We'll get into it more, but it kind of seems to be a real common barrier for food operations, is having a contaminated worker or a sick worker that actually spreads their contamination on the food and then thus gets it to the consumer. So you have to be very cognizant about separate types of equipment, how to clean and sanitize. When you get into large-scale operations, they're going to have their third shift. They come in and completely clean, sanitize everything. And of course, this does happen in your supermarkets and your restaurants as well. So having a good standard operating procedure program where you do have some clean-in-place programs maybe, or just a good sanitation program becomes very vital for the safety of the food in that operation. Another thing you do, and this next one, this slide, is really more towards certain types of operation. The food prep at different times, prepare raw meat, seafood, and poultry at different times than you would a ready-to-eat food. And this is something that's very useful even in your own home. Don't use the same type of cutting boards. Make sure that everything is separate. Make sure you do the ready-to-eat foods first, which is really hard to do because in food prep you do have to cook foods that are necessary to cook first. So it does become very tough to prepare something like a ready-to-eat food like a salad or something and then put it back in the fridge or leave it out. But it is something we need to do. Also, restaurants do buy a lot of prepared foods. They buy food items that don't require a lot of prepping or handling, so it decreases the risk of contamination and also the time and temperature abuse that could be problematic for spreading contamination. Okay, when you're looking at time and temperature abuse, there's a couple of things you'll see on this slide that can really help us avoid time and temperature abuse. One of the best things is to look at the most appropriate way to monitor time and temperature. Is it with a specific type of thermometer? When is the best times to do it? Is it continuous? Is it once a day, twice a day? Determine the best way to actually monitor all those things every 30 minutes, whatever it is. Also, make sure that we have thermometers readily available for each type of operation. Make sure they are calibrated to the right type. You can use the ice point or the boiling point method to make sure that the accuracy is very consistent on those things with what is actually being recorded. Also, we talked about record regular temperatures in the times they are taken. Again, those are preset intervals. Usually depends on if in your HACCP plan or in the standard operating procedures. More likely they are going to be in your HACCP plan. Also minimize the time the food spends in the temperature danger zone. If you think about a packing plant, the ultimate job of a beef packing plant is to cool the carcasses down as quickly as possible without doing it too quickly. There's some other side effects that can happen because of that. So whether it's cooling the carcass down from the kill floor on, or if we're doing food prep, we don't want to leave any of those objects in that 70 to 90 degrees room temperature for more than 4 to 6 hours. That's kind of the standard time. That gives microorganisms enough time to acclimate and reproduce. And then take corrective actions if the temperatures are not met. When it comes to the time and temperature control, one of the biggest things we can do is know that microorganisms do grow best at temperatures between 41 and 135, which is 5 and 57 degrees Celsius, and that's basically the temperature danger zone. Okay. Most of them will grow best right in the middle of that zone, between 70 and 125 degrees. Okay. But we talked about the best ways to determine corrective actions, how to do all this stuff, but you got to have the right thermometer. So most of them will choose to use a bimetallic stem thermometer, that you can see on this slide. It has your indicator head in degrees Celsius or degrees Fahrenheit or both. There's some objectives it has to have to make sure it's good, and those are on page 5-6 in your book. It has to have an adjustable calibration nut, which you can see there. That's adjustable so that we can use the ice point or boiling point method to calibrate it. Make sure it's easy to read, has numbered temperature markings, which you can see on the dial face. Also needs a dimple mark to the end of the sensing area. Basically from that line you can see the top of the sensing area to the end, it takes an average temperature over that entire region. And you can see where the actual little dimple is. From that to the tip is the sensing area. Okay? But it has to be accurate also within plus or minus 2 degrees Fahrenheit, which is plus or minus 1 degree Celsius, for you to use it in a food operation. A couple other types of thermometers include thermocouples and thermistors. Okay, but you can find these on page 5-7. Basically, they measure temperatures through a metal probe or a sensing area and display results usually on a digital type of readout. Okay, most commonly that's what you are going to find. Most of them come with interchangeable probes, where they're really small types of, even little, almost like a piece of wire to a regular type of probe like you'd find on a regular thermometer. Okay. The different types of probes include an immersion, a surface, penetration, and an air probe. Okay. Obviously, immersions are made for liquids like soups and sauces. The surface ones are for flat cooking equipment like griddles. You can also have some that go in to penetrate things. And last but not least, of course, the air temperature might need to be measured inside a refrigerator or something like that. So, a couple of different ways that you can look at a thermocouple or a thermistor type of thermometer. Okay, I've talked about the ice point and boiling point methods. To calibrate a thermometer, and this is the ice point method. Basically what you do is fill the large container with crushed ice as small as possible and water. And basically let it sit for a little bit, not too long, because obviously it's going to start to warm up the room temperature eventually. Okay. Then you put the thermometer stem or probe into the water, and let it sit there until the dial quits moving. Okay. And then we adjust it to 32 degrees. Really pretty simple. This is the ice plate method. Okay. And you can see on your slide that this one only has degrees Fahrenheit. Typically a lot of them will have both if you really need it. A lot of internal temperatures, they tell you, are in degrees centigrade. But hopefully you'll learn a little bit of both throughout this chapter and also throughout this course. Some general guidelines that you can utilize for thermometers. Of course, make sure that you keep thermometers in their storage cases clean. They can become contaminated. They need to be sanitized regularly. Most of the time with calibration, most places I know, if they're doing a lot of cold temperature indicators or foods, they will do the ice point method daily. And that usually occurs to large packing plants, and they'll do the hot point or boiling point method maybe once a week. Okay. Also regularly check the accuracy of thermometers in coolers and freezers. Make sure they are right, and that's when a surface one or infrared would be very useful. Never use a glass thermometer to monitor food temperature ever. The glass can break, it becomes a physical hazard. Of course, most of the time mercury-loaded ones, which you probably shouldn't see anymore, but you never know. They can't be used either because they can become a toxic substance. Make sure we insert the thermometer stem or the probe into the thickest part of the product, the center. Whether you're talking about something that's cold like a carcass, talking about a ribeye roll, or you're talking about a beef roast that's cooked. Make sure that we get the internal temperature. That is what we're looking for. And last but not least, make sure that the temperature is steady and has not moved. This basically concludes Chapter 5 or Section 5 about time, temperature, abuse, a little bit of contamination. Make sure to review your questions, your quizzes, and get them submitted to me through email. Thank you.